Um, but earlier in when we started learning about systems, we learned that a system with two linear equations has um, three possible outcomes. So let's just write that down. A system of linear equations has three possible outcomes. And so this is when you have two unknowns, x and y, which means we have two equations. Okay. We can have the most common outcome, which is one solution. And let's make a quick little coordinate plane grid. There's the y-axis. Here's the x-axis. And normally, when you just have two lines, they will intersect at one place, and that's it. You can have one line doing something like this, negative slope. And then say we have another line over here with a positive slope. And they just cross somewhere. They intersect. And this XY location, well, that's our solution, right? And there's only one. Okay? That's the part we've been solving for all this time. We've always had one solution. Um, what other possibilities can we have? Remember, we can have no solution? So let's graph what that looks like. Mm, Does anyone recall what I'm going to graph next? Parallel lines, yeah. So one line, and another line, and they're parallel. And that tells us we have no solution. So graphically, one solution is two lines cross at some point, and that's it. They only cross once. No solutions is two lines never cross, so they're parallel. And then we can have, yes, infinitely many solutions. Um, Let's graph something that would be infinitely many solutions. Oops. Anybody remember what this would look like? What we say is they coincide. They overlap basically. So you have one line, you graph it, and then the second line gets graphed, and it turns out to cover the same space two-dimensionally. So we say that the lines coincide. Lines coincide. All right. So those are the three possibilities. The first one's the most common. It happens all the time. The other two happen every so often. So we want to know how to tell when we have one solution, no solutions, and infinitely many solutions algebraically, not without graphing. And we don't have to solve our equations or solve the system all the way to figure it out. We want to just get to a certain point and say, okay, we are going to get a solution. Because today we're not going to care what the solution is, just is it one, will it be none, or will it be infinitely many? Okay, so that's what we're going to work on today, determining algebraically when we have one of these three possibilities. Okay, let's get to it. Let's start with the one we're most familiar with, one solution. So we're going to write a system, and this one will have one solution for sure. Okay. So one solution. Here we go. 5x plus 4y equals negative 30, and 3x minus 9y equals negative 18. Okay, so write that down. Here's the system. And we're going to just try to solve it. And the moment we can tell, okay, we are going to get something for the moment one of the two variables cancels out. The moment we can determine that, that's when we say, okay, this is one solution. We're not going to have the other possibilities. So let's see if we can solve it for either x or y. Like, let's see here. What do you want to get rid of? X or y? X? Let's get rid of x. Okay, so we got 5 and 3 for our coefficients. So since they're both positive, one of them has to be negative. Is there a number that 3 and 5 go into? Common number that 15. Yeah, that's going to be it. So that means we multiply one of them by the top one by 3, the bottom one by 5, and one of those two has to be negative. So let's do that. So you just do what you normally do to get rid of one of the variables. So let's see. Let's make the top one negative. Let's make the bottom one just 5. That way we'll have negative 15 and positive 15. All right. So solving this, we get negative 15x minus 12y equals 90. Okay. Now we're going to have 15x minus 45y equals negative 90. Okay, well, let's see what this gives us. Well, these cancel, of course. That was the whole purpose. And that's going to be negative 57 y equals 0. Now, did we eliminate the x variable successfully? The moment you see that you eliminate just one of the two, you can stop there and say, we are going to have just one solution. Okay? If it so happens that both of them cancel out, if I would have had x's and y's cancel out, then it's going to be one of the others. It's going to either be no solution or infinitely many. So I could stop here. I could stop here and say, I'm going to get some, well, what's y going to be? 0. Y is going to be 0. So I got something for y, which means eventually I'll get something for x. So I could stop there and say, that's it. We have one solution. Okay? So since we successfully eliminated one of the variables, even if the constants turn out to be 0, like in this case, that's okay. Comma, we have one solution. Okay. So basically what you do is go ahead and try to solve it like we normally do. The moment you see you get rid of just x or y, you could say we have one solution. Okay. Any questions on that? So just try to get rid of one of the variables. If one of the variables successfully cancels out, you're done. You know you have one solution. Okay? Any questions on that? Okay. Let's try to go for no solution. So this is going to be an example of how to determine you have no solution. Okay. So here's one for you. Negative 2x minus 6y equals negative 1. And we have negative x minus 3y equals positive 1. Okay, write that one. So we can either get rid of x's or y's. Again, which one is the least work to do? X. If I want to get rid of x, I would multiply this bottom equation with something that would give me a positive 2. So what do I want to multiply through by? Negative 2. Negative times negative is positive. I would have 2y there. Let's see what happens. So this stays negative 2x minus 6y equals negative 1. That stays the same. Over here we get 2x plus 6y equals negative 2. Okay, notice what happens here. What do you see? Well, let's cancel. All right. So obviously negative 2x and positive 2x cancel. But what happens here? It cancels also. So x's and y's cancel. Sound familiar from when we had equations and the variable would go away? So we end up with, well, what's on the left side? Nothing. So 0. So we end up with, it's going to be a no solution. Here's why. 0 here. And over here we got negative 3. So we have a statement again. And the statement is false. So from here we could say we had a false statement, which is 0 equals negative 3, which is not true. Therefore, no solution. And what kind of lines would that be? Mm-hmm. Remember that symbol for parallel? Okay, so basically you solve it as you normally would. All the variables go away. You end up with 0 on the left and anything other than 0 on the right. So therefore, no solution. Okay. So now we'll move on to the last thing. Infinitely many solutions. Infinitely many solutions. Let's see how that's going to happen. Let's write down 4x minus 12y equals 22, and negative 2x plus 6y equals negative 11. Something real obvious like that. Okay, let's try to get rid of x's again. Well, it doesn't matter, actually. Let's try to get rid of y's. What do I have to do to make this positive 12y to cancel that one? Multiply by 2. So you just solve it like you normally would. See what you get. In this case, I get 4x minus 12y equals 22. And then I'm going to get negative 4x minus or plus 12y equals negative 22. Okay, so let's see what that gives us. I got 4x and negative 4x, that's 0. Negative 12y and positive 12y, that's 0. So 0 here. How about on the other side? 0. 22 take away 22 is also 0. So I end up with 0 equals 0. Not an exciting statement, but is it true? Yeah, it's true. This is a statement again. And that's what's going to happen. You're going to see everything cancel just on both sides. You get 0 on the left, 0 on the right, and you're going to end up with a true statement. Pretty much always 0 equals 0. So therefore, infinitely many solutions. And lines are going to coincide. If I were to go back and graph both these lines, one would basically overlap the other. Okay. So the assignment today is not to solve systems. It's basically determine what kind you have. One solution, infinitely many solutions, or no solution. Okay. So they actually go quickly because you don't have to go all the way through to solve them.